Hey guys, if you're new here, I'm Jake, and I recently used AlgoExpert to land a job at Google. The question I always get is how, when, where, who, what do I do with AlgoExpert to get the same results as you? And while I can't guarantee anything, today I want to teach by demonstration how I studied with AlgoExpert, and hopefully that's helpful. I'm going to be trying to solve one of their free questions they have on their site. This is my first time seeing it, and throughout that, hopefully we can laugh at some of my mistakes and learn how to leverage the tool for studying. So let's get started. All right, the question is shift a linked list. I've never seen this one before. It is difficulty hard. This is the prompt. Let's take a look through. Write a function that takes in the head of a singly linked list an integer k, shifts the list in place, doesn't create a brand new list by k positions, and returns its new head. So shifting a linked list means moving its nodes forward or backward and wrapping them around the list where appropriate. For example, shifting a linked list forward by one position would make its tail become the new head of the linked list. Whether nodes are moved forward or backward is determined by whether k is positive or negative. Each linked list node has an integer value as well as a next node pointing to the next node in the list, or to none or null if it's at the tail of the list. You can assume that the input linked list will always have at least one node. In other words, the head will never be none or null. So then we have some examples here, with head equaling 0, with a next to 1, to a next to 2, to a next to a 3, to a next to a 4, to a next to a 5. And then we have k equals 2. So I guess that if it's positive, then we would, then we would have an output of 4, the next to 5, to the next to 0. So what happened here? Did the tail became the head, and then it was 5, 0, 1, 2, 3, 4, and then the 4 was the tail, and then that became the head again. So then it was, okay, now 4, 5, 0, 1, 2, 3. I see. So there's 2 iterations of the tail becoming the head. Okay. Well, that's nice. Okay, I think I have a decent understanding of what the question is. I'm gonna take 60 seconds and just quietly reflect on my thoughts and see and think about what I think the solution could be. Okay, cool. So I don't know if I have the exact solution, figured out, but I do have some ideas, so I'd like to get started. First of all, I probably won't be testing, so I'm just going to minimize this and kind of beef up my code window. And I might make this text a little bit bigger so that we can get in here. So one thing I noticed, and I'm gonna go to, okay, you can't use a scratch pad unless you have an account. That's kind of lame. That would have been nice. I also can't copy the input. Okay, that's kind of frustrating. Okay, that's fine. I'll just make my scratch pad right here. So the way I look at it, so we have head equals 0. Let me just copy out some of this input real quick. 2, 3, 4, 5. And then we have k equals 2. And the expected output is 4. What am I doing here? 5, 0, 1, 2, 3. Okay, so essentially we've rotated this linked list so that this 4 and 5 are now at the beginning. The way I look at this is actually there's 2 distinct operations. I mean, if k is positive, then we will be rotating the linked list by adding what's at the beginning to, what's at the end, what's the tail, to the head. And then vice versa. If k is negative, we'll be putting what's at the head at the tail. So this could be broken down into smaller operations. Instead of taking 2, 4, and 5 and putting them at the head, you could also look at it as just an operation of taking the tail and putting it as the head and then repeating that on the result. So really, this could be you could break down this operation into two steps. The first step being taking the tail and putting it as the head so that you have 5, 0, 1, 2, you see where I'm going with this, 3, 4, and then taking this result and just repeating that operation to get here. And then like vice versa, if we had the same thing but it was negative, I think you would just do the same exact thing, except in the opposite fashion. So we would be taking the head and placing it as the tail. So the first operation would be, the head would then be 1, 2, 3, 4, 5, 0. And then we put the head as the tail again and get 2, 3, 4, 5, 0, 1. So I think breaking it down into these smaller steps would probably be a little bit of an easier way to think about it. May or may not be the fastest way to handle it. But then from here, if you want to break it down into these equations, then the question becomes, okay, how do we, in this scenario, how do we swap the tail and the head? Okay, and then in this scenario, how do we, well, I guess the same thing. 1, 2, 3, 4, 5, 0. I guess this is more append. How do we append the head to the tail? And then this is how do we, prepend the tail to the head? I don't know, maybe that's a confusing way to word that, but similar operations in different directions. If I can figure out how to do this, then I would just repeat the operation as many times as necessary on the linked list. And what's nice about this is that it's not creating a new linked list, because I believe that it's specified here. Shifting the linked lists means moving them around where necessary. Doesn't create a brand new linked list. Okay. So let's drill deep into like the exact operation. How necessarily would you prepend the tail to the head? Actually, I think it might be easier to start with appending the head to the tail. I think that's easier to do. So I think here what we would do is, how do we append the head to the tail? Well, you can always iterate through the linked list, or yeah, that's fine. So we could iterate to the end and then append a node to it. I think that would be fine. So why don't we iterate? So like I don't know, set up a variable to track the head node. So save the head node in a temp variable. Once again, maybe there's a better way to do this, but save the head node in the temp variable. Iterate through the list until. So okay, so this is another thing I thought about. If I'll finish this line of thought, but it'll iterate through the list until you find the tail. Set tail.next equal the head, and then set head.next equal to null. So an issue here, I think, is that once you do this, how do you return the head of the modified linked list? Unless this is like completely modifying an existing, no, that wouldn't change anything. We need a reference to the new head, because if we take a reference to this variable and then we iterate all the way to the end, append this to the tail, and then set its next to null, well, how do we get a reference to the new head, which would be 2? I think that could be done perhaps in this step here before we set head.next equal to null. We could save a reference to what it is. So maybe like set set new head temp variable to head.next, and then set head.next to null. That might work since it's a reference type. So this is interesting. Would something similar work for the top? Because now what we're doing is, in this situation, we're iterating through, and we are trying to place the last item as the new head. Okay, so in this situation, we need to break the second to last item's next reference. We need to set the next reference of the last item to the head, and then return that item. So let's see. We would be iterating through, and once we reach this step, and we can see that the next item's next is null, we need to break this reference and then set this one's next to equal the head. So I think we still need a temp variable pointing towards the head, because we will need to access that later. And then we're going to iterate through the list until you find the tail. In this case, I think you need to find the item before the tail. Then we need to set the item before the tail's next. Well, first of all, we need to save a reference to it. So save set tail temp variable. Then item before the tail will be null. And then, so then that effectively breaks the list right here. But we still have a reference to the tail item. So we can set tail item, or tail temp, dot next equals the head that we saved previously. And then we should just be able to return the tail temp as the new head. And sorry, here I never wrote what we're returning. So we save the head node in the temp variable, iterate through the list till you find the tail, set tail next to the head, and set the new head temp variable head next, and set head next on null, and return the new head. Okay. So, I mean, this looks like decent pseudocode. I know I still haven't done like the control flow that would actually like call these sub functions, but let's, first of all, I think that this is like predicated on a lot of assumptions. So it'd be worth it to begin coding and see if I can implement this the way I think. And if we can't get an implementation, then come back to the drawing board with these basic blocks. So, okay, so we have a linked list class here. We're given a head and a K. Okay. So let's get started here. So what do we want to call these two functions? How about prepend and append? All right, so just open up some functions. Okay, so let's do this one first. So this would be prepend. So I'm just gonna copy these notes up into here. Okay, save the head node on a temp. Okay, const temp head equals list. Great. Iterate through the list until you find the item before the tail. Okay, cur equals list. Okay, this is also going to be let cur equals list while cur dot next probably just make this a one-liner. Cur equals cur.next. So what this does is just, while there is a next item, just keep iterating down the list. Eventually cur.next will equal null. And, oh, I'm sorry. Iterate through the list until you find the item before the tail. Okay, so cur.next.next, because we want to make sure that this item's next item also has a next item. Eventually this will be false because the next item's next will point to nothing, because we will be at the item before the last item, and then we will stop iterating. So this, the last item before the tail. Okay, set a tail temp variable. Okay, let tail temp equal cur.next. Set item before the tail.next equal null. Okay, so then we want to do cur.next equals null. So this breaks the item before the tail's next reference. And then we set the tail temp's next to equal the head. So tail temp.next is going to now equal our temp head. And we return the tail temp. Okay. I mean, this is kind of how my pseudocode was written. I don't necessarily know if this is going to work. Like, for example, here, why don't we just run console.log head, then let's do prepend, oh, by the way, and then we'll do console.log prepend list, sorry, head. Can't type. All right, yeah, I know that this is gonna fit. Oh, you can't even run the code? Oh, it wants me to, okay, cool, hold on. Okay, yeah, that was just giving me some trouble. Anyway, I know this is gonna fail. I wanna see the raw output. Okay, so here's our linked list, value 1, value 5. Oh, it only passed me 2 items. Okay, real quick, let's just make a function print list. And what this is just gonna do is just say while list.next console.log list.value. That's what it's called, right? Yeah, value. Oops. Actually, wait, I don't even need to do that. Yeah, hold on. List equals list.next. Okay, so yeah, let's just do this. I'm gonna wrap everything in a print function, just because that will probably look a little bit better. Let's confirm that that does what I think it does. It does. Beautiful. Okay. Now we want to print prepend list, or sorry, head. Yeah, I'm curious to see if this does what I think it does. Okay, so it starts out with, how many numbers are there? 4, 5. Okay, so each list has 5 items. So it starts out with 0, 1, 2, 3, 4. And now we have 5, 0, 1, 2, 3. Okay, beautiful. That actually worked. That actually worked. That I have to color me surprised. I'm a little surprised my first attempt at that worked. Okay, so now we need to implement the append list. So if we go into here, drop these comments in. All right. So one more time. Save the head node in temp variable. Const temp head equals list. Iterate through the list until you find the tail. Okay, I'm gonna copy some code from up here. So let cur equal list while cur.next. This time we actually do want the head, so just cur.next, cur equals cur.next. Eventually, cur.next will equal null. That's because we are at the tail. Iterate through the list till you find the tail. Set the tail next to equal the head. Okay, so cur.next is going to equal our temp head. All right, and now we have a circular list. Set new head temp variable equal to head.next. Set new head temp variable equal to head.next. Okay. So this would be const new head is going to equal our existing head.next. And now we want to set head next equal to null. Also, head's not a variable, so what we wanted to do is this, actually. New head is temp head.next, temp head.next equals null. And then we return the new head. Okay, so let's give this a shot. So as opposed to 5, 0, 1, 2, 3, I'm going to expect 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. I'm going to expect 1, 2, 3, 4, 5, 0. 0 being appended to the end. Okay, so 1, 2, 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. This seems wrong. Hold on. Let's remove my print. How many items are in this linked list? 0, 1, 2, 3, 4. Okay, where is 5 coming from? There should be 5 items, 0 to 4. So if I print append, I get 0, 1, 2, 3, 4. That's expected. Now I'm getting 1, 2, 3, 4, 5. Did this happen when I did prepend? Zero, 1, 2, 3, 4, 5, 0, 1, 2, 3. How? I'm so confused. Hold on. No, yeah, show me the test. How many? Okay, so there is a 5 in this item. Okay, cool. Okay, so this data set has a 5 in it. There's 6 items in it. So whatever my print function's not working properly. Console list.value list.next. Okay, that's the problem. Okay, we need to print the tail, which we're not doing. Okie dokie. All right, kids, we got this figured out now. Let's check out what happens now. So okay, I'm gonna print the head and then I'm going to append the head. Let's see what that looks like. 0, 1, 2, 3, 4, 5, and then we get 1, 2, 3, 4, 5, 0. Okay, perfect. Append worked how I thought it would. Prepend. 0, 1, 2, 3, 4, 5, 5, 0, 1, 2, 3, 4. Okay, perfect. All right, everything's working the way I think it will. So, I mean, I think that's fine. The pseudocode seemed to do what I thought it would do. Obviously, like I should have vocalized this from the beginning, but there will be issues when there is not that many items. I know that it's mentioned in here. You only can assume that the list will have at least 1 item. Obviously, prepending and looping through things isn't going to work if there's only 1 item. So, but let's just focus on this now. So, prepending is supposed to happen when k is positive. So, let's just say, how do we want to do this? So if k is more than 0, I don't know, while k does not equal 0, k minus minus, and then head equals prepend head. And else if k is less than 0, while k does not equal 0, head equals append head, and then k plus plus, and then return head. Yeah, and honestly, this could be simplified here. Well, yeah, I guess the easiest way to do this would just be like const iterations equals math.abs. I think that's the function, k, and then const function func equals k more than 0. If k is more than 0, then it's prepend, otherwise it's append. First class functions, okay. And then, yeah, hypothetically, let's save the making it look cooler for later. Let's just try to do this for now. Okay, so let's run this and see. Okay, test case 1 passed. That's great. Really quickly, let's try to do the let's try to clean it up by removing all of these if checks. And then we can just do while iterations does not equal 0. Then we want to head equals func head k minus minus. Okay, or sorry, iterations minus minus minus. This just removes all of this control flow logic that's not really necessary. Assignment to constant oh, well, that would do it. Okay, that worked. So, okay, what handling do I need to do if the lengths are different? If we can say, oh, well, that's an interesting question. If head.next is equal to null, then there's only one item in the list. So we can just return head. If there are 2 items in the list, then I think you would just swap them. Because if you append or if you prepend, there's no difference in the new order. Yeah, right? I'm not crazy, right? Let me think about this. Yeah, so I mean, if it's 1 or 2, if you prepend, then it becomes 2, 1. If you, yeah, it doesn't matter. If there's 2 items, you're just constantly switching it. So you would just swap the items k amount of times. And if there's 3 items, then my thing works, because this system just relies on you finding the one system relies on you like modifying the head and the tail, and one system relies on you modifying the head, the tail, and the item before. So I think the bare minimum for this system to work is having 3 items. So I just need to have a handler for 2 items. So is there any like quick function I can make just called swap? Head. So const temp head equals head. Const temp tail equals head.next. So then we want to send temp tail. We want to set temp head.next equals null. Temp tail.next equals temp head, and then return temp head. Is that right? No, temp tail, sorry. So we grab the temp heads next, break that link between the 2 items, set the tails next to the head, and then return the tail. Okay, okay, so in this case, instead of doing this like append prepend stuff, we would just say if head.next is equal to null, then we just want to var x equals 0. X is x is less than math.abs for k, x plus plus. Okay. Then we just do head equals swap head. And I know I probably went through that kind of quickly, but the point behind that is that since the prepend and append depend on there at least being 3 items in the list, they don't work if there's only 2 items in the list. But the good thing is, if there's only 2 items in the list, it doesn't matter if you prepend or append, you're essentially just switching the 2 items. So all I have to do is take that list and run a switch on those to swap on those 2 items k amount of times. Okay. So I'm gonna run this code again, and okay, I'm gonna submit it. And congratulations, your submission passed all of our test cases. I did it. Yay! So that was only 33 minutes. I guess some good exercises here would be, can we find the big O notation and for the time and speed complexity of this operation, and is there a better way to do it? I'm gonna congratulate myself with a drink. Great. Yeah, so this may or may not be the fastest way to handle this. So let's just break it down into the prepend operations. So the prepend operation iterates through the list one time. And then we have some temp variables. This would just be O of n. The size of the list won't change the amount of space being taken up by. It'll always be 3 of the nodes we're saving. The speed will be linear. As the list grows longer, iterating through it will take longer. And each time we prepend, we iterate through one time. So if there's five prepend operations, then we iterate through 5 times. Now, something I was thinking about when I was initially looking at solving this is that if the order of the items within the prepend is not changing, then it's not necessary to do it one by one. So I broke it down for simplicity's sake. Like, for example, if, like, say k is 3, this is a better example. If k is 3, then we would be prepending 5, and then we prepend 4, and then we prepend 3. But, wouldn't it be simpler to just highlight this whole section and say, okay, the last 3 items of the list are now going to be at the beginning, and they're going to be reversed. So hypothetically, we could just iterate through the list, grab these 3 items, and then reverse them and append them to the beginning. In that case, we would only be iterating through the list one time to find the section, and then we would iterate through the list another time to reverse that section, and then we would assign it to the beginning. So that way you have like one full pass through the entire list, a second pass through a subsection of the list, and then some assignment, and then that would be it. And that would probably be a better solution, because if you imagine if this list was like 10,000 things long and we needed to prepend 3,000 of them, well, then the algorithm I wrote is iterating through 3,000 times the entire list to grab the last item and put it at the front. So that's not very efficient. And then in the case of appending, here we are going to move this first thing to the very end. And the nice thing about appending is that this changes into 1, 2, 3, 4, 5, 0, 1. The nice thing about appending is the subsection that we're removing from the beginning and putting at the end doesn't need to be reversed. It's in order. So we could highlight the subsection by iterating through until we have the subsection, and then iterating to the end, and then just tacking that subsection on. And so again, this would have the same benefit of only iterating through 2 times, having some assignments be more efficient. So yeah, I think my solution is still linear that I provided. As the list grows longer, it will have to iterate more times. But I guess if I had implemented this second algorithm I'm proposing right now, it would have been O2n. Sorry, I'm saying that wrong. It would have been, if n is the size of the list, it would have been O of 2n. Now, I have no idea what I'm saying right now. Basically, no matter how long the list is, you'd only have to iterate through it twice. As opposed to, yeah. I think that would be a better solution. I think that's the only thing I can think of as far as speeding this algorithm up. And how, like, let's see, are there any edge cases to consider? I mean, I know it says that you'll always have 1 item, but if you have 0 items, it's never bad to just have, a null check. You could also do checks on k to make sure that like it's a proper int. It's not like like overflowing or a max or something like that. Also, you could have a check if it's 0, because I mean, if like if k is equal to 0, then there's no operation required. You don't need to go any further. So some parameter checks here. Oops. So that would make it a little cleaner. Okay, we can just add some more comments here. Handle param validation. Handle only 2 items in list. And we would just call this append or prepend as necessary. And we don't need this anymore. Okay. Well, I think in retrospect, I could have done better on this problem. I think I took the easy brute force method, and while that was nice because I didn't run into many problems while implementing this and I was able to come up with a solution, I think that if I had been a little bit more adventurous and just kind of followed my intuition in the beginning, I probably could have identified the faster way to accomplish this with a better algorithm. So that's one problem I have with how I did this, but not bad. So I guess let's take this last couple minutes just to look at the solution and see what the better way of doing it was, and if so the list length is equal to 1. They just make that assumption. Then they set the attempts equal to the head and call it the tail. And then they iterate to the end until they have the tail. Okay, cool. Yeah, so they're grabbing the tail here. Then they get the absolute of k and get the modulo of the list length. Where did they get the list length? Oh, sorry. They set it as 1 initially. This is just a check to say if k is a high enough number that everything would rotate in place, just return the list as it is, because there's no reason in operating on it. Okay, that makes sense. Basically, if you have a list full of 3 items and you have to do 3 appends on it, there's no point in doing the appends. It's going to give you the same list back. Okay, got it. Okay, New tail position is going to equal, if k is more than 0, then list length minus the offset, or it's the offset. Oh, that's interesting. So it's basically using the amount of operations we're going to do in reference to the list length to determine the new tail position. And then it sets new tail, temp variable, equal to the head, and iterates through the list until it finds the new tail position. Okay, so they're basically approaching this and just ignoring whether we're appending or prepending, whether it's a negative or positive number. They don't really care. This approach is actually even more straightforward than the one I proposed by like appending whole sections or prepending whole sections. Basically, they're determining the new tail position and then iterating through until they find that. And then they grab the head, which would be the next item, and then just break that and rearrange the list. I'm doing a terrible job explaining this. I'm going to watch the video. See, here's a pointer. Once you solve, whether you solve it or you don't solve it, after like 40, 45 minutes, if you still don't absolutely completely understand the perfect solution, that's when you click the video explanation and you just watch the video explanation. Problem solved. All right, guys, that's it for me today. I think to summarize my approach, it's good to pretend like you're actually kind of in an interview when you do these study questions, and make sure that you read the problem, you completely understand it, you do some pseudocode, and really dive into your approach before you jump into coding. Make sure you talk out loud. Obviously, if you're studying and doing these problems all day, you don't have to talk out loud for every single problem, or else you're going to annoy everybody, but it's certainly helpful because people expect that during interviews. Make sure you talk about, you think about the space and time complexity. Make sure you talk about edge case scenario and how you would test your algorithm and how you would speed it up or improve it, and your thought process throughout that. And there's nothing wrong if you get stuck. If you can't figure out the solution, that's okay. If you've been spending 40 or 45 minutes on a problem and you still can't figure it out, just skip to the solution. Try to figure out the solution. There's no one saying that you have to brute force your way through every single problem, and that would be incredibly inefficient to learn. So yeah, hopefully you learn something from my approach, and if you can replicate it, I think it's a decent way to study and work through these problems so that you can learn. So yeah, thanks for watching, and see you next time.